It's Thursday. And that means that it is another episode of Thursdays with Tolga. Tolga is a certified SSPC protective coating specialist, coatings inspector, and a professional instructor. Today's topic is multi-coat versus single coat systems. If you enjoy this episode, please like and share this video. If you're not subscribed to this channel, please make sure to subscribe and set your notifications to all, so that you won't miss any new content. Every Sunday on LinkedIn, see a new 2-minute lessons release.
This is Jim Kunkel. Welcome to another episode of Thursdays with Tolga. This afternoon, Tolga and I will be talking about multi-coat versus single coat systems. Hey Tolga, how you doing today?
Fine. I'm doing great, James. Well, how about you?
Very good. You know what day is today?
Thursday?
It's Thursday.
Thursday with you and me.
Well, Thursdays with Tolga for sure. Hey Tolga, the last week's episode that we had when we were talking about the contractor quality control and the owner quality assurance, it was a hit. A lot of great feedback. People appreciated the information that you covered. A lot of them said that we could probably go on and on and on for hours talking about the subject matter. So great job last week.
Thanks. I also get. I'm glad to be with you and do this broadcasting. So the comments you just told me is also very flattering. Thank you. Thank you very much, James.
It's not a problem. So, hey, Tolga, what topic are we going to talk about this Thursday?
This Thursday, James, we're going to talk about a very hot topic, like in a hot summer day. It's about multi-coat system versus single coat system. Probably you know that it's a very long-going debate over the recent years.
Well, Tolga, for those who might not know what a multi-coat system is, can you explain basically what they are comprised of?
Yeah, for sure, James. Okay, let's think of this skyscraper. It is the Dubai Burj Khalifa, the tallest skyscraper in the world. Why I'm showing this to you, James, is because it's one of the world's hardest business in the world, constructing skyscraper. So what are they doing as construction professionals? First, they are using the soil as a substrate, and they are doing the concrete preparation, surface preparation for foundation. So then the first for the skyscraper or ground floors, then the top floors and the roof. So this is basically it's very simple. It seems like simple, but it takes sometimes months, several months, and then sometimes years. And to honestly speaking, I'm not a professional on the construction, but anyone who would like to read something about steel buildings and construction, I put a link there, and you can put a link below about steel buildings in Europe.
No, I'll definitely do that. That's a good representation. So you're talking about, basically you have a foundation and then you have several layers built on top of it to ultimately get the world's tallest skyscraper.
Yes, definitely. You're right. Definitely.
So I was going to say, how does that tie into multi-coat systems?
Yeah, it's basically the same as construction engineering. We have everything very similar, but we are using different concepts. But these concepts can be can be read from the ISO standard from 4618. This can be freely accessed with this link below. And what is critical is the substrate first, James. Actually, this is I call it a triangle, but with 4 elements. The first is substrate. the substrate is the basis of the, is like a foundation of the building. Then comes the paint and coating material, right? Right now we'll be talking about a lot of things about coatings, paint and coating material, but we will first take a brief summary of this, and then surface preparation. We can think as it is a adhesive between paint coating material and paint coating layers. So because if there is no adhesive, if there is no glue, nobody can attach anything to a material, a concrete, wood. So its surface preparation is like a glue between the paint and coating material and the paint and coating layers. So we will come to this a little bit later, why surface preparation is important, because we are mentioning this as a coating, paint or coating system, not a paint or coating process.
Well, I was going to say, as we all learn in the industry, over 80% or sometimes even more failures happen because of improper surface preparation. So
that's right, Jim. But I would like thanks for stressing this. This coating failures is basically what you have said to me, that 80% of the worldwide coating premature failures is coming from surface preparation. You're definitely right. So so basically, what a multi-coat system. So let's begin with multi-coat systems, because everybody knows, or at least believes that he knows or she knows that multi-coat system is. But we'll try to describe it in simple terms. So what is a multiple or multi-coat system? So multi-coat system is basically, as you can see is from this sketch, is based off substrate plus surface preparation. What I mean by substrate, it can be any metal like iron, steel. So steel is a big family of, is a great family of metal, like carbon steel, galvanized steel, stainless steel, or weathering steel. You call it, James. And then comes another metal, aluminum, and then comes copper. So this can go on and go on. But we are not going into details, just covering the basics. So other than the metals, there is also concrete one. The concrete is also very important because most of the buildings are concrete. And then plastics, wood, like plastics, automotive plastics, and then the wood and the composites. But these substrates are not meaningful or are not functional without without required surface preparation for the coating system, James, like solvent cleaning, SP1, or mechanical or tool cleaning, abrasive blasting, water jetting, water blasting, and so on, you name it. So this makes the first basis of the coating system. So, and then starting from the first layer, which is the primer coat, is the function. Its function is the corrosion and chemical protection and adhesion and bonding surface. And then after primer coats, and by the way, let me give you some example of primer coats. Probably most of our professional like you and me and other people watching us know that zinc-rich primers, inorganic zinc or organic zinc primers, phenolics, epoxies, polyurethanes, hot dip galvanizer also is a good primer, metallizing. So these are all examples of primer coats.
So the primer coat will sacrifice itself when it has zinc inside of it.
That's right. So it's one of the protection mechanism is sacrificing, and the other one is barrier mechanism, and the other one is inhibition, which we are not going into details, but in other classes, in other episodes, maybe we can go into that these also.
Perfect.
Corrosion protection mechanisms, as you call it. And then comes in this multi-coat system, the intermediate coats and our we can say also in the literature undercoats, which is basically serve as a toughness or impermeability or surface bonding surface as a top coat. We will just in a minute show. So then, what are some examples of intermediate coats? We can say alkyds, epoxies, like as a primer epoxy or intermediate epoxy, phenolics, again, and sealers. So basically, it's like primer coats, but in different functionality. But it's more tough and more impermeable. So more as you can see, it's more thicker than the primer coat. DFT, the dry film thickness is much greater.
Okay.
And then comes the final or finish or top coat. So basically, it's mostly mainly aesthetics, color and gloss pattern, color retention, gloss retention, weathering resistance, color stability, UV stability, abrasion resistance, so on. So it's for outdoor, mainly the first defense of outdoor weathering. This finish and top coats.
That's to protect it from the external environment, be it the sun, be it abrasion, be it any other type of elements that might be nearby.
You're right. And these are some, let me give you some examples of the chemistries, acrylic resins, acrylic coatings, modified alkyds and epoxies. They also have top coats. Polyurethanes, but be careful about polyurethanes. We will go into details later in this episode. This is aliphatic polyurethane, not an aromatic polyurethane. Other advanced polymeric top coats we will also be discussing later in this episode, like POLYSILOXANEs, polyaspartics, POLYUREA, and so on. And why these multi-coat definition systems are, okay, we'll cover definitions in briefly, but why they are important to the industry, James? Because there are industrial and international standards used worldwide. So let me give you some examples. One of the first is, by the way, I'm giving it in the alphabetic order. Australian New Zealand standard 2312 for this is a joint standard with Australia and New Zealand standards. And second, these are also these standards that we are mentioning is covering the selection of coatings or protective coatings or paints for corrosion protection. So the other one is, probably you heard that, for International Standards Organization 1212944 is a very popular nowadays in the world. So basically, last year the last year it was revised, completely revised. And there is the NORSOK standards. So NORSOK is for Norwegian offshore industry standards, and the most common popular one is M501. And then comes the SSPC paint system standards, James.
Okay, these are basically the series that are available out there for the industry. Is that correct?
That's right, James.
Okay, I understand.
In these standards, because we cannot show it all the way, but in these standards, there are a couple of numerous tables that a professional can use to select the paint or coating system in terms of their expectation, life expectancies, or environmental or any chemical expectancies. So there are the tables are inside the standards are very, very helpful.
So depending on what commodity might be associated with the asset or the service environment where it's located at, there's tables that will say, in this situation, you should look at this coating system. Is that correct?
Exactly.
Perfect.
Exactly, Jim.
Perfect.
So This is basically one of the important. These are the one of the most important standards in the coating and paint and coating industry worldwide, James. By the way,
so
and there are a lot of papers on that in the internet. Mm-hmm.
So Tolga, one coat systems are really gaining in popularity. They're being added into project specifications. Can you explain, what polysporadic and polysiloxane systems are and what advantages they provide?
James, starting from the 1990s and also especially in the 21st century, you're right that single coat systems are gaining popularity because of some of the advantages they are providing. So let me give you the definition or simple definition of the single coat systems is the paint and coating systems that combines primer, intermediate and finish coats. So it is basically, we can formalize it like that: substrate plus surface preparation as a glue or as a connection, and the paint and coating material. This is just one layer or single layer system, but it is not a single pass application, James, which means as we will go through like polyurea, polyaspartics or polysiloxanes, the thicknesses cannot be applied in one single pass. It can be applied in several passes. I mean, in several passes of conventional or airless spray systems. So the popular technologies are traditional single coat systems. By the way, before the newest systems, like we will talk about in a minute, there are traditional ones like good old economic alkyds. There are one coat alkyds. There are one coat single coat acrylics that is called direct to metal or TEERM. There are polyurethanes. But be careful of polyurethanes. This is not, most of the time, this is not an aliphatic polyurethane, it's an aromatic polyurethane. And inorganic zinc coatings, the famous inorganic zinc coatings, ethyl silicates, alkyl silicates, and hot dip galvanizer is a coating also, not a paint, but it's a coating. And thermal spray, metallizing is also another one coat system. So, for example, this is the Morgan Vale pipeline from Australia, and can you believe it, James? It is more than 50 years of lifetime, and it doesn't show any coating failure, and it has just one coat of inorganic zinc.
Yeah, it looks really good.
Inorganic zinc is not a new concept, but there are new technologies that are coming into our lives. That is a new concept.
Very interesting.
Like polymeric coatings with advanced technologies, like that you are mentioned before, polyaspartics, polysiloxanes, polyurea, and there is also one fluoropolymers, but I didn't put it here because most of the time these are the most main parts that you will see in the literature or in the specifications. Okay. So let me begin with polyurea. What a polyurea is. In the literature or in the scientific notation, it is abbreviated as PUA. And it is the resultant chemical formed via the chemical reaction between the aromatic or aliphatic isocyanate and the resin mixture and component. It's a polymer. So it's like polyurethane, but unlike polyurethane, there is an polyamine component. So it's isocyanate in the polyurethane, but the polyamine is different than polyurethane. So it's a much more dense, very high dense cross-linked chemical product, chemical coating. So there is part A, part B, two-component system. So it's a pure polyurea, polyurethane hybrid, as we have just mentioned. It's derived from polyurethane chemistry, but it can be also. There are some products. There are some chemical products in the market. There is a hybrid of polyurea, polyurethane. This is the part B. The isocyanate component can be aromatic or aliphatic. And as you can see here, it requires a special equipment to be applied. But it gives the coating professionals some of the advantages and some superior properties like better color and gloss retention, better elongation and flexibility, excellent chemical resistance. Believe me, these are one of the most chemical and solvent resistant product in the world. Applicability in lower temperatures. Some of the, depending on the formulation, some of the polyureas can be applied in minus 0 degrees, so below freezing degrees temperatures.
Interesting.
And better thermal shock resistance than polyurethanes and other coatings. Shorter turnaround, depending on the formulation again, James, the curing or the drying can be in minutes and even in seconds. So you count it, James, 1, 2, 3, and it dries and cures. It's just simple. Just like, because of this very short drying and curing, this equipment is also special. You cannot use any conventional or airless spray with a pure polyurea or polyurethane hybrids. So you need to have some kind of a two-component specialized equipment to apply polyurea.
And as I understand with polyurea too, depending on the formulation, the chemistry, it can be modified to go and do different types of applications. I think the picture you have there looks like a bridge deck, or what is that structure?
I think it's a roof.
A roof. I
think it's a roof.
It could be used.
But I'm not sure.
Yeah, it could be used in a swimming pool. It could be used on a roof. It could be used on a bridge deck.
Right.
It could be put into other type of service environments. So, and it's all depending on the type of formulation that's required to be able to handle the application or the environment. So very interesting material. To your point about the application, it takes specialized training when it comes to the operation of the equipment, and then the applicator, obviously, they have to make sure they know exactly what they're doing. It's not a conventional type of a paint system. As to your point, it dries, it cures, sets and cures so fast and rapidly that you really have to know what you're doing when you're working with this material.
You're right, James, what you have said. And also, there are some very nice comprehensive standards from SSPC, like SSPC paint number 39, for SSPC paint 45, and paint for application and selection of polyureas. But finally, about polyurea, a good friend of mine, Dudley Premio, I call it the polyurea guy. I think he's one of the first scientists or first businessman in the world about polyurea. He knows everything about polyurea, and also he is also having trainings in the United States, in the world, about polyurea. So he's much better in knowledge and experience than me. I should point that.
I will agree. Although you have great knowledge, I will agree that when it comes to polyurea and a lot of other things, Dudley Primo is the top of the line when it comes to knowledge of this stuff, and been there, done it. He's got the experience. So. Good guy.
Yeah, you're right. Okay, enough for the polyurea. Let's move on to polyaspartics. Actually, it's also like a polyurea, but it's developed by Covestro, which is formerly a Bayer Material Science, in the 90s as a coating for steel in bridges, used for corrosion in resistant properties. So it's a hybrid material that is an extension of polyurea, as I mentioned, and a polyurethane chemical technology. And pure polyurea reacts extremely quickly, as we mentioned, like in minutes and even in seconds. So to make it more easily applicable without using plural component spray equipment, they have modified, the Bayer Material Science or Covestro guys have modified this polyurea, and they also call it this aliphatic polyurea polyaspartic. and it's shortly call it PAS or ASP in the literature. So it's also it can be applied with conventional airless application equipments. So what is it in chemical terms? What is it? It's a product partially blocked by amine polymers with aliphatic isocyanates, replacing the polyol with the A site. In the polyurethane, the part A is the polyol, but in the polyaspartic, is the part A is the polyaspartic aspartate, and there is the part B, which is the isocyanate. So so we can say that it's an polyaspartic is an aliphatic polyurea without the need for specialized application equipments. And they have similar advantages and superior properties like polyureas. But depending on the manufacturers, because the manufacturers are playing with the amount of the ester to customize polyaspartic, they can have different technical properties, such as quick drying times or a little bit slower drying times, limited gas emissions like low emissions after application. And these are direct to metal as one coat, one single layer coating applications are also possible, but be careful about that. It's mainly for atmospheric service, like rail cars. And today it can be applied to a variety of surfaces, not just on the steel, but also on concrete, James.
Mm.
So anything you would like to add about polyaspartic, Jim?
No, I think for me, I'm learning a lot from you about this. It's, some of these aspects I'm not 100, as good as you are when it comes to the knowledge of this stuff, and I'm learning a lot as well. So I appreciate you going through this.
Okay, then. Okay, then we'll move on to polysiloxanes. Mm-hmm. It's called polysiloxane because it's a resultant chemical formed by chemical reactions between silicon oxygen siloxane inorganic chemical polymers with organic polymers, epoxy-like. So basically, this is like the chemical representation of polysiloxanes, or shortly we can say PSX. It's a famous brand of one paint manufacturer, or SLX. Some of the in technical studies they are mentioning it's polysiloxane as SLX. So it's this polysiloxane is an hybrid of organic and inorganic polysiloxanes. So there are basically two hybrid polysiloxanes, James. One is first is the epoxy polysiloxane hybrids, and second is the acrylic polysiloxane hybrids. And an optimum level of organic modification is generally required, like 20 to 30%. So it's the manufacturers are also playing around with the organic modification of the polysiloxanes. So up to today, James, there are 3 generations of polysiloxanes. So right now we are in the 3rd generation of polysiloxanes. In the first and second one, there are some problems. There are also, you can, if you just Google it, just search on the net, you can see that because of the polysiloxanes, there are some coating failures. But from the 3rd generation, the coating manufacturers makes much more stable polysiloxanes. Unfortunately, no industrial international standard like POLYUREA or polyaspartic, James. Generally replacing 2-coat epoxy polyurethane system with a single coat. So we are replacing the 2-coat system with a single coat of polysiloxane. Advantages and superior properties are similar to other ones, but excellent gloss retention, color properties, last longer than polyurethane acrylic counterparts. It's also rapid curing, not like polyurea, but definitely incompressible with polyaspartic. Low VOC product, sprayable with a conventional spray, unlike polyurea or other high polymer coatings. Conventional spray, they are also giving it as a option. and there is no isocyanate. So the biggest, James, the biggest difference in POLYSILOXANE is the no isocyanate. In the chemistry, there is no isocyanate, which is why it's important, because in some of the countries in the world, like Australia and New Zealand, there are some regulations that you cannot isocyanate in the product, in the coating or paint product. So that's why they cannot use POLYUREA or polyurethane or polyaspartic if you are living in Australia or in New Zealand.
Interesting.
But up to now, we have talked about single coats, but what we should say about single coat is there are some of the times the single coat may not be enough, adequate, because the heavy duty industry needs much more, sometimes tougher coatings or corrosion resistance. There comes the single coatings. Single coat may not be adequate. So that's why some of the studies or reports we will investigate in a couple of minutes state that two coats is much better than single coat. So basically, what I mean by two coat is in the traditional three coat system, there is the steel substrate and surface preparation, epoxy zinc or inorganic zinc primer, epoxy intermediate coat, and polyurethane. So we are right now omitting the intermediate coat, and we are putting it top coat like polyurea, polyaspartic, and polysiloxane top coats. So this is important because not every time you cannot use single coats, James, for every industry or for every environment, depending on the coating formulation also.
Interesting. Okay. Very interesting. So, Tolga, has there been any comparison testing done on multi-coat versus a single coat systems? And if so, is there any interesting results that you would like to talk to the viewers about?
Yes, James. There are a couple of very interesting, very exciting multi-coat, single-coat test studies and reports in the world. The first one is coming from, it's a very comprehensive one, is coming from United States Department of Defense, DOT, Federal Highway Administration. This is their report coming from publication number this in 2011. And they are, in summary, they are saying that as a conclusion, they have studied 8 one-coat system and 2 controls, a 3-coat and a 2-coat system, so totally 10 systems of coating. And they have this 10 coating system. They have carried out accelerated laboratory testing and 2 outdoor conditions, exposure conditions, like 18 months and 24 months of outdoor exposure conditions, natural weathering. And they have done it in the coating and corrosion laboratory in Turner Fairbank Highway Research Center. It's a very, very big corrosion laboratory, by the way, very comprehensive. And another outdoor exposure was performed at a marine exposure site in New Jersey, United States. So in conclusion, they said that although some of the one-coat system demonstrated promising performance, none of them performed as well as the 3-coat in accelerated laboratory test and the outdoor exposure conditions. But notice that this is a 2011 study, so things may be improved. So, but there is there are some nice findings in the laboratory tests. But they just say that it's not the best in the 10 of the systems, 10 coating systems.
Interesting.
The other one is, sorry?
Very interesting.
Mm-hmm. The other one is coming from the NASA, National Aeronautical Space Administration. And there is a corrosion technology laboratory there in technology evaluation. They have a program called Technology Evaluation for Environmental Risk Mitigation. And there's a report on October 20th, 2016. So they are saying that several one-code systems with 2 codes or 3 codes have been compared with via this laboratory tests for zones of exposure. And they have also said that similar things to the United States, the Federal Agency, the administration. And there is also Northeast Protective Coating NEP code study in 1997. And they are saying that, yes, the one code system is okay, but we are not, they are not also giving the best or evaluating as the best of the products, best of the coding systems evaluated. And there is the national, sorry?
No, go ahead.
Okay. There is a National Shipbuilding Research Program, NSRP. They have a study called Compatibility of Single Coat Tank Coatings with Retained Pre-Construction Primer and done prepared by Asley Technology Corporation. And also they have some one code systems, but in terms of one code system, the 3 codes are outperform the one code systems. And finally, there is the SSPC, as you know, SSPC Painting System Guide 7, but it's mostly for temporary protection, not for long-term protection. This document covers the indoor environments. So
it looks like over the last decade, there's several different tests that kind of compare both multi-coat and single coat, and they come up with different findings. Are you going to go through those findings or cover that material that was discovered?
Yes, we will just now go into the findings. We will just summarize it right now,
Perfect.
Jim.
Go ahead.
But we should firstly ask some questions before summarizing. What are we going to, if we want to select a single coat, what should we care about? Firstly, we should care about surface environment, conditions surrounding surface, because not every surface environment, conditions surrounding surface may not be the same. So there are ISO corrosivity categories and SSPC environmental zones that covers some service environment. And what is the service life, James? Is it just 1 month or 12 months, or is it 25 years or more? What are the application requirements? What are the humidity, temperature, environmentals? Do you need special tools, equipment, trained operators, staff? So and what are the safety and environmental compliances? Like, is there any local or federal or national or international regulation like VOC limits, from EPA, from in the United States, or OTC, or in Europe, the SED, Solvent Emission Directive in Europe. So finally, the budget. What is your budget? What do you want to? How much money? What do you want to pay? Because these products can be quite expensive, Jane, because they are very highly advanced chemical products. So the findings that has been given in this study so far is I'm just summarizing this table, James. Firstly, there is in multi-coat there is more number of layers, but in single coat less number of layers. In multi-coat systems, most of the time there is more amount of material due to higher DFT, and there is more amount of solvents used. And in single coat, there is less amount of material due to low DFT. So the more DFT, less DFT. Since it's the number of layers is less than is more in multi-coat systems, 3-layer, 4-layer. It's more application time needed for applying, for spraying, for stripe coating. but in single coat, there is less application time. And when it comes to drying and curing times, James, you need to have more drying and curing time. And one of the most important things in selecting the single coat or two coat system, because it will be less drying and curing time needed. And in multi-coat systems, there is a need for less sophisticated. Even you can use it by brush or conventional air spray, but when you go to single coat systems, they are much more technology advanced, and you need to have more sophisticated tools and equipments. And therefore, you need to have more experience, because you need to have more sophisticated tools. You need to have more experienced applicators. And in some of the times, if you need to apply these, you need to have some certified applicators for using these tools and equipments.
Interesting.
And yes, and the whole points, as we covered in QN and QC episode with you, the more number of checkpoints, like the more stop points or hold points we have it in multi-coat systems, but in single coat, apparently there is less number of checkpoints. But due to more number of layers, there is more premature coating failure because of the delamination or other coating failure risk, more premature. In single coat, since there is one coat, less premature coating failure risk. And in multi-coat system, because of the case histories, and because of the variety, there you can have much more options to select from. But in single coat, not every paint or coating in manufacturer can manufacture these highly advanced polymeric materials. And in and one of the most important things, since the environment is getting more popular and more critical in nowadays, there is more solvent emissions in multi-coat systems, but in single coat systems, definitely it will be less solvent emissions, because there won't be much paint or solvent used in single coat systems. And
go ahead.
And lastly, James, okay, these can be seen as separate two different systems, but in one project, you may have to apply single coat and multi-coat systems together, like this offshore wind tower. Like in the basement, you may need to use much more multi-coat system, but in the atmospheric ones, maybe you can use or one coat system. So depending on the conditions or depending on the project parameters, you may need to use single coat and multi-coat system together, James.
Very interesting. Very interesting. You know, Tolga, this has been a great conversation, and once again, you nailed it. You did an awesome job on this discussion related to multi-coat and single coat. You know, in kind of closing out this Thursday, is there anything else that you'd want to cover with the viewers?
James, yes. In closing thoughts, I would like to say that in our lives, nothing is perfect as we are living right now. So what do I mean by nothing is perfect in terms of paints and coatings? In every painting or coating system, there is advantages and disadvantages. There is pros and cons. So, and in addition to that, there are several industries. Which industry you are in, like nuclear, marine, industrial, aerospace, petroleum, oil, or highways, you name it, or agriculture. So depending on that, the paint system, coating system will change dramatically. And also, we need to remember that a paint or coating system is not just one bucket or one can of paint. It's a system approach with the four things let me remind you, or let me go again. Substrate, surface preparation, paint and coating material, paint and coating layers together. So there are also hundreds, if not thousands, of variables here. So it's a very complicated multi-discipline area to construct a single coat or multi-coat system. So as I mentioned before in our latest episode, my favorite quote is coming from a British mathematician, is from Mr. Alfred Whitehead, is we think in generalities, but we live in detail. And this is about this.
Yeah, so true, so true. So,
okay.
Tolga,
would you like to add something about multi-coat or multi-coat single coat systems or anything else, Jim?
What I will say is I learned a lot because these systems that are available, you have traditional systems, and now you're having these more advanced and specialized coating systems. And now that as we advance in time, the technology continually changes, and I can't wait to see what the next products that are going to be coming out. And I'm sure they're going to be more getting in line of these single coats, or these maybe two coat systems and things like that. But on top of that, it also comes into play that we in the industry have to make sure that we stay on top of not only the products and the technology, but also the standards, and also to the testing methodologies that are required to make sure that the projects are being done properly and there's quality in the finished product. Tolga had...
I definitely agree with you, James. What you said, the testing methods and the standards with the coating materials is very crucial in terms of quality.
And Tolga had a couple links into this presentation, which I will include in the video description on YouTube, so that people can link to that to get to see the additional information. And as you can see, Tolga has his blog site, his website, which I highly encourage everyone.
It's a technical blog site. I mean, nothing non-profit technical blog site, by the way.
Yeah, I encourage people to take a look at that at the corrosiondoctor.org, and also too, there's the email address for Tolga if you do want to reach out to him if you have any additional questions. Tolga, is there anything else you want to add before we would close up this Thursday?
I look forward to. I would look forward to meet again in our next episode, Jim.
Perfect.
I hope it's interesting and beneficial for the audience.
I'm so far, like I say, after our first episode, a lot of great feedback. I'm sure this will get a lot of great feedback. And as we continue on, I'm sure we're going to build a pretty good following, and have a lot of people provide us additional topics that they would want to have us talk about. So Tolga, I appreciate spending this Thursday with you. Have a great rest of your day.
You are welcome. Yeah, you are welcome, James. Have a great rest of the day. Bye for now.